Okay, let's do this. Let's do the math.
Kind of up to over 4.
-2 plus 4 plus 2. -4 plus 2 is 2. The absolute value of 2 plus 2 is 4. My first ordered pair is going to be at -2 comma 4. That's what I want you to do right now.
Should it be down? Or would it be up?
Alright, let's continue in our table. I'm going to put, so I'm plugging in for x, right? -1 plus 4 plus 2. That's 3 plus 2. That's 5. -1 comma 5. There's our ordered pairs. We're going to plot them. Yeah, I'm plugging in for x in the equation. Good question. Why would you be moving it to the left instead of the right? You're going to see it. So let's draw this and see what it looks like.
Not this. I got this wrong. Wait, what?
Yeah.
I feel like it ain't fair for the people to be close to the bathroom.
Why did I forget that?
We don't need to talk about it.
For something that ain't even our fault. Cause I got in trouble for that already. Like, it's my first day back and I already got in trouble for that.
Alright, so I've plotted my points in orange. So, this is an absolute value function, but it doesn't have the V shape. Though we use our tried and true table method, we don't have a V shape. Does the table method work for this graph? No. What I'm observing here, and I'm hoping you're observing, is the reason that the sheet I gave you yesterday for the transformations is so necessary. If you're relying on a table, like you can for lots of graphs, you're not going to get a full picture of your absolute value graph. You need a V, or you have not graphed the function. So, what we could do, which a lot of people do that don't know transformations or don't know how to see where shifts lie, is they just keep going with the table. So we could go 3, 4, 5, 6, and keep going. But what if it just keeps going forever, right? We might end up with just a straight line. So we have to know the transformations to find the V, to find the vertex. So did I tell you the name of the vertex? Or did I tell you that that point is called a vertex? this little point, that's called a vertex, but you learned that, right? Okay. So going back to what we covered yesterday, and if you want to get out your handout, you can. We're going to use this to help us make a really good table. You need this handout? I gave 2 people this handout. Who else needs it? The table is just to show you why understanding the transformations is necessary to graph. Okay. So looking up, A is 1, so we don't have to think about our orange line being reflected. This this plus 4, according to what I told you yesterday, should do what to the graph? The horizontal move, that's called H. It's called a horizontal translation. And even though it's plus 4, that's always opposite. So I'm expecting a horizontal translation of -4. And somebody else, what does the plus 2 at the end do? Yeah. Vertical translation of +2. Okay? There was also in the very last example a tip about vertex. The vertex, which is the point of the graph, is that this ordered pair H comma K. So for our graph, we should have an ordered pair at -4, 2, and that should be the vertex. So I want you to extend your table down. Let's put -4 at the bottom of this table. And let's see if what we've written here about the vertex is true. Plug -4 into the equation and see what you get out. What do we get? 2. We get 0 plus 2, 2. Sweet, sweet. Why did I? Because I saw in the equation that it was an important point. You always do the opposite of this. So if it looks like +4, you do -4. Okay. So sure enough, when we put -4 in, we got 2 out. So there's our ordered pair. So now, before I'm just graphing these points kind of lost, not sure when this thing's going to take that V turn. But now I know, because of my knowledge about transformations, -4, 2 is the vertex, right? So now I can keep my table knowledge going too. So now if I want to get the rest of the shape, a vertex means the line's going to come down and bounce back up. Let's do 2 more points in our table. Let's do like -5 and -6. Let's do -5 and -6 and get a good picture. Plug them in, draw them. So my points are -5, 3 and -6, 4. You see it. Now I can see the important part of the graph, the vertex. So if you're asked to graph an absolute value function and you don't have the vertex, if you don't have the V shape, you haven't done it. You need to find that vertex. And now you know the vertex is just the numbers in the H and K spot. Does anybody have a question? Yes. No. So what I'm trying to say is actually never use this table. Okay, so I set you guys up doing this problem a very long way so that you understand the importance of knowing transformations. Mm-hmm. So, Max, did you hear what she said?
What?
Okay, well, you were saying there was no point. The point was for you to come across this moment. Say it again.
You start the table with the vertex and you can just go up and down.
So when you make a table, you should start at this ordered pair and do 2 to the left or do 2 to the right. Or you can graph the way we did yesterday on the handout, knowing your transformations, shift left or right, up or down, and that's going to get you a good graph as well. Okay? So I'm just justifying the process to you. A lot of students want to know, Mrs. Baldwin, why is all this stuff true? You know, why are you just telling me this and I'm supposed to believe in it? So I'm just trying to show you why the process works. It's more of a comprehensive understanding. So looking at the picture, your arrows go left and right forever. So what's your domain? All real numbers.
Range is like X.
Let him try. Let him try. You got it. You got it? Why is what? Oh, I thought you had it. Somebody else. What is the range? Who hasn't given an answer? Yes? The 4 is a 2. 2. This is your range, your shift up. Yes. Domain for absolute value functions is. Okay, but the domain for the piecewise functions where the lines were going crazy all over the place, that wasn't always auto numbers. This one, yes, always auto numbers. All right, this is it. Last bit for this first part of class.
Oh my lord.
So start with this. Everybody start by writing this model down. This is the model you have to have memorized for your absolute value function. I like that question. So the slope goes here in the A spot. I talked about that yesterday. Okay, well let's start with the vertex. Who can tell me, somebody who has not given an answer, what is the vertex of the green line? Gabby, did you even answer today?
I don't even know.
Okay, Gabby, you go.
-4, +2.
Okay, here's our vertex at -4, +2. The word for that is vertex. Maybe that's just starting to sink in with you. I'm throwing that word out there like you know it. Maybe you're starting to get it. So, okay, so this is my model. I'm going to write x minus -4 plus 2. Okay, so what about A? So A is supposed to show reflections and it's supposed to show slopes. So, does the green line have a reflection as compared to the red line? Yes, so we got to put a negative sign in our equation. And then, the green line's looking very skinny. Very skinny. So that's because the slope is something other than up 1 over 1, up 1 over 1. So can anybody tell the slope where you're setting? Savannah? Yeah, -4 over 1. So we're going to be y equals -4. We don't need to put over 1. All things are over 1. Absolute value. This is going to become plus 2. So writing equation given a picture, very much an SAT type question. They show you a graph and you got to pick, which one's going to be. Identify the vertex. Identify the slope. If it's reflected, put your negative sign in there. Okay, I'll give you guys a minute to look over your notes and do number 4 and 5. So in number 4, I'm really looking for the vocabulary that you wrote down. I've already said it out loud, so write it down. Like lots of vocabulary. And when it says identify transformations, I'm looking for, is there a horizontal translation? Holly, I'm looking for vertical translations. I'm looking for reflections. I'm looking for the word stretch or compression. A whole 4 sentences here. So how does this one look different than the parent red function?
I didn't do my bio work.
What did you say? Let's go on test.
You
You don't feel capable of making one sentence? Let's hear you do it. I'm asking him to make one before he talks about biomed. One sentence. Because what I just heard from you is I have no idea, so I'm going to talk about something else. Yes? No, so if you want to shorthand, it's fine, but 4 vocabulary words. How about that? Let me have here. Let's just do the vocab.
Wait, I think I have horizontal.
Yes, I love it. Of how much?
What? 4, right?
I'm going to actually say specifically -4.
Okay.
All right, good. Here we go.
Oh wait, I
Who
have
else
another
wants to
one.
get one? Okay, Paige.
A vertical translation of +2.
Yes, it's up to. Bailey? You were here yesterday? Okay, can you tell me now? Reflections. Okay. I did just now. So all of them are going to be reflections across X. But I want to throw it in there because sometimes it's talked about, where is it reflected? These are all across X, so I didn't even mention it yesterday. There's a lot to talk about yesterday. But if you want to specify across X-axis, it is more formal, more definitive. Last one, what is it? Torian. I'm going to go ahead and say vertical stretch of 4. Let's talk about why I put 4 instead of -4. So the negative is already described in the word reflection. The stretch is a factor of 4. It's been so the slope is 4, so every y value is 4 times higher than those y values. And so when we talk about stretches and compressions, we disregard the negative sign. And that's why those absolute value bars were in those definitions yesterday that were so confusing. So that's the same thing here. It's like you think of it just the positive number. Okay, we're almost done, and this is a full review of what we covered for the whole class yesterday. So it probably feels like a lot, but it is a full review. Domain and range. Somebody asked me, what's the domain? Domain is always our real numbers for these. Matt, what's the range? Matthew. Uh-huh. Yeah, you got it. Good job. It might have felt a little painful, but that was a full review of what we covered yesterday.